All right, I'm back to graphing here. So if I plug in -1, I get +2 take away 1, which is 1. So I go -1 and 1. If I plug in 0, I get 3 take away 1. Sorry, 0. If I plug in -2, I get -2 plus 3, which is 1. Absolute value 1 is 1. Take away 1 is 0. I'm going to do it one more time. I'm going to plug in -3. If I plug in -3, I get -3 plus 3 is 0. Take away 1 is -1. So it keeps it keeps going down this way. But if I plug in -4, then you get +1. It goes back up to 0. I want to understand that this absolute value has a vertex at -3 and -1, and that's within my piece that I'm drawing. So I have a sense of this to the right. I have a sense of this as a line going up with the same slope to the right. So I'm aware of the vertex and where the vertex might be. If I'm drawing a piece of this absolute value and the vertex is not included, it's just going to look like a line. But I need to know if the vertex is part of the piece or not to draw it accurately. The second one is just a line, so that's simple. So plug in 0 and you get -5. It's a point. So 1, 2, 3, down here. -5. And the slope. Up 2 and to the right 1. That's it. And you've drawn the piecewise. The domain is all real numbers. So for every number there's an answer to get. The range, if you look really carefully, this is the bottom. So the bottom is at what x value? That's -5, and it goes up forever from there. Is there a discontinuity? Yes, at 0, right? It's not continuous. What's happening there? It's a jump at x equals 0. All right, turn the page. Understand what piece you're graphing. So the top piece is a line, and it starts at -3. So at -3, I'm going to plug in. I'm going to be careful because the negative times the negative is positive. So it's when I substitute in -3, I get +3 and -4. So that's -1. So go to -3 and -1. Notice there's a line underneath the arrow, so it's a point. And what's the slope? So the slope is down 1 and to the right 1, but I'm not going to draw it to the right. I'm only going to draw it to the left. So from that point, the slope is down 1 and to the right 1, but I only draw it up to that point, from the left to that point, and I don't go to the right of it. So to the right of -3, what does the picture look like? It's a parabola, and that parabola is folding down, and it's -1/2. So I got to be aware of the vertex to make sure I include it. So I get a good sense the vertex is at 0 and 0, knowing this is in vertex form. But I'm still going to plug in -3. And when you get that, you get +9 divided by -2. So it's -4.5. So when I plug in -3, I get 9 and half of 9, right? And it's a negative answer. And that's going to be a whole. So at -3, -4.5. 1, 2, 3, 4.5. And it's a whole. 0, 0 is going to be the vertex. I can plug in other points to help. So if I plug in -2, that might help. Like do a little table of values for yourself. That's 4 and divided by -2. So -2 and -2. -1 might help. That gives me -1/2. So you can see what's happening up here to 0. And then after 0, you can use the axis of symmetry to get more points on the other side. So you can see one piece is a line and the other piece is a parabola. The domain of this is all real numbers. The range, so the top part of the range to the bottom part. So the range actually is all real numbers. Is there a discontinuity? Yep, at x equals -3, there's a jump. And you did it. All right, let's keep practicing until we get it right. Number 5. The top piece is a rational function. Might have an asymptote in there. The bottom piece is a line. So let's start with the bottom piece because it's a little easier. So I have 1. So when I plug in 1, the answer is -5. And it's a hole. So at 1 and -5, I have a hole. And there's a line from there. And the slope of that line is up 2 and to the right 1. And then I just draw my line going to the right, doing that. Well, what else do I have in here? The top piece is a rational function. So what I recognize is the denominator, that x cannot equal -3, and it's a part of my domain. So -3 is smaller than 1. So at -3 we have an asymptote. We have another asymptote because the numerator is a degree smaller than the denominator. It's 0. Now we're going to plug in some points that are going to be hopefully helpful to us. So I want to plug in a point to the right and left of what I see. So I'm going to plug in -2 because that's going to be helpful to get a point on the right side of the asymptote. So -2 gives me the answer 4. If on the other side of the asymptote, which is -4, I get the answer -4. That's going to be helpful too. The y-axis, if I wanted to, it crosses at 1 1/3. Now it's important that exactly here it's going to stop. So if I plug 1 into here, I get 4 divided by 4, which is 1. So right there at 1, it's going to stop. So at 1, 1, plugging in the domain restriction, that's going to be an important point, and I know I stop there. On this side, it's going to go down forever, and then as it goes up, it curves, and it's going to follow the asymptote there. The domain of this, well, there's one number x cannot be. So we know that it's all real numbers, but x cannot equal -3. The range, well, it goes down forever and it goes up forever, so you can see the two ends there. So the range is all real numbers. Is there a discontinuity? Well, there's 2 of them. So one is the asymptote at x equals -3. It's a vertical asymptote. And the other discontinuity is where there's a jump, which is at x equals 1. Number 6, 3 pieces. So we'll try to make it simple. The top piece is a line, and it starts at -4. So I'm going to plug -4 into the top piece. 3 times -4, that's -12, plus 8, that's -4. So I'm going to start there, and it's a point. It is not a hole because of the line underneath the arrow. So at -4 and -4, we have a point. And it's a line, and the slope of the line is 3. Now, if I go up 3 and over 1, I'm going to the right, but I'm going to the left with this line. So I'm going to count down 3 and to the left 1, and then draw my line there. The next piece is a horizontal line. -1 is just horizontal. So from -4 to 2, so at -4 and -1, we have a hole. But at 2 and -1, we have a point, and that number is a constant, and that when you graph a constant, it just graphs to be a horizontal line. The last piece is a parabola, so I'm going to first plug in 2. And if I plug in 2, I get 0 and negative 5. Oh, if I plug in 2, I get the answer negative 5. So I'm going to go to 2 and negative 5. That's a hole because there's an arrow there. I know the vertex is at 2 and negative 5. So that 2 is very good. The next point, if I plug in 3, I'm going to get the answer negative 4. If I plug in 4, I'm going to get the answer negative 1. And I can see what's happening here to the right. The domain is all real numbers. The range is also all real numbers. Are there any discontinuities? There's 2 of them. So at x equals negative 4, there's a jump. And at x equals 2, there's a jump. All right, last one like this. 3 pieces. So when it's less than negative 1, 7. That means it's a horizontal line at 7. So I'm going to go negative 1 and 7. Now, when I do that, I recognize it's a hole, and just going to the left is that horizontal line. It looks just like that. Next, it's a cube function from negative 1 to 2. So I'm going to plug in negative 1, and I get the answer negative 2. It's a point. If I plug in 0, I get negative 1. If I plug in 1, I get 0. If I plug in 2, I get 8 take away 1, which is 7. And that's going to be a point. So I have it curving up here, ends, and curve here, and it ends. One more piece. This is a square root to graph. I'm going to plug in 2 to begin with. So plugging in 2, 2 times 2 is 4. The square root of 4 is 2. Negative 2 plus 1. So that gives me negative 1. So at 2, the answer is negative 1, and it's a hole. And it's going to curve, so think of how it's going to curve from there. So we can plug in another number that would make sense that I could actually perhaps graph. So the next one that would make sense would be like 8. Is that on my graph? 4, 5, 6, 7, yeah, 8. And the reason 8 makes sense, because 2 times 8 is 16. The square root of 16 is 4. And negative 4 plus 1 is negative 3. So I have 8 and negative 3. That gives me a sense of the direction of the curve going this way. So you can see the square root curving down to the right there. The domain is all real numbers. The range, well, the bottom is negative infinity, but the top is actually the horizontal line, which is 7, and it's included. But there's nothing above 7. Discontinuity, there's 2 of them. One is at x equals 1, and it's a jump. And the other is at x equals 2, and it's a jump. Sorry, this should say negative 1. Both are jumps. So at x equals negative 1, we have a jump, and at x equals 2, we have a jump. So good practicing piecewise. Let me do another video on the practice sheet homework. So the hope would be that you practice it first, and then we'll go through the video together to see if you did it right.